In this tutorial, we want to look at some unusual cases you might run into when solving these nonlinear inequalities. For instance, in this case, we would normally like to try to find the zero, but let's take a look at the graph of this function. As you can see, there actually is no point where it crosses the x-axis, so this function doesn't have any zeros. So in this case, we're looking for the points where the function is less than zero. Um, Looking at this graph, we see that it never dips below the x-axis, so it actually is never less than zero, and therefore we can go with the null set for our answer to this inequality. So if we continue looking at this function x squared plus 2x plus 3, but um, we look at this other inequality where it's greater than or equal to 0, we can see that the function is always above the x-axis, so it's always greater than 0. So unlike the first one where it was never less than 0, we can say that this one is greater than or equal to 0 on the interval all the way from negative infinity to positive infinity. So basically all real numbers. All right, this next function, we should be able to factor pretty easily to find what our zero would be. And when we do that, we get, when we set x squared plus 12x plus 36 equal to 0, um, we're going to get x plus 6, x plus 6, since 6 and 6 add to 12, and they also multiply to 36. And that's going to make me have 1 0 at x equals negative 6. It happens twice there, but we really only end up with 1 0. And when we pull up the graph, you can see that it just kind of dips down and touches that x-axis at one point, negative 6. So basically what our answer is going to be is everything except this negative 6 here. So in interval form, we'll want to write from negative infinity all the way to 6, not including it, of course, or at negative 6, and union with negative 6 all the way to positive infinity. So finally, if we look at this last case here, which is the opposite of what we just had, now we have this function. We want to know when it is less than or equal to 0. And of course, it's never less than 0, and it's only equal to 0 at that one point, negative 6. So really our answer here is basically you could just say x equals negative 6. Or you could write it embraces as a set. So let's just look at this last example here. Go ahead and see if you can figure out the solution to this inequality using any technique to find zeros that you're comfortable with.